Hello ACES students, it's time to learn how to draw some atoms, so get out your own paper and away we go. We're going to call this Drawing Atom Notes. And in order to draw atoms, you first have to know which elements you want to draw off the periodic table. Let's take carbon for instance. If you were to look on the periodic table, you would see a box that looks something like this. It's got a C in the middle for carbon, it's got a 6 either in the top or the top right hand corner, and it's got a 12 in the bottom, or perhaps it says 12.011. This top number right here is called the atomic number. And the atomic number is the number that tells you the element's identity. And the atomic number is the number of protons that element has. This number down here is the atomic mass number. And the atomic mass number tells you the number of protons and neutrons. And the reason it tells you the number of protons and neutrons is because it tells you the entire mass of the atom. And the mass of the atom, the atom's mass, is only protons and neutrons, because as you guys know, electrons are up to 2,000 or so times smaller, and so they essentially, I wrote over here, they essentially weigh nothing. So these guys right here, atomic number, atomic mass number, those are your keys to drawing atoms. So let's draw carbon. All right, to draw carbon, I'm going to start with this number 12, and I'm going to draw 12 particles from my nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know that's my nucleus because the only thing that weighs anything in my atom is my nucleus. Now, of those 12 particles, this number 6 tells me that 6 of them are protons. So I'm going to color in maybe 1, 2, 3, 4, 5, and 6. So 6 of those are protons. Maybe I'll make a little key over here. So I've got, say, okay, these things right here, these are protons. These clear things right here are neutrons. And what am I missing? Oh, that's right, electrons. So let's make little triangles maybe. We're going to call these things electrons. And where do the electrons go? Well, remember from that simulation we did in class earlier that the electrons are different distances away from the nucleus. And we're going to follow what I like to call the 2-8-8 rule. And the 2-8-8 rule is I start with my first 2 electrons are going to be the closest possible in that inner orbital. So let's draw maybe like a little triangle here and a little triangle here. I'm going to say d d d d d d d d d d d d d d. Those first 2 electrons are right there in that orbital. And now how many do I have left? Oh, well, I have to draw 6 because I want to have the same number of electrons as protons. So I've got 4 left. So maybe I'll go 1, 2, 3, 4. And again, I'll do dotted lines all the way around. D D D D D D D D D D D D D D D D D D D D. And so now I have 1, 2, 3, 4, 5, 6. And I'm following my 2-8-8 rule. The first 2 go in the first orbital, and then up to 8 more can go in this one, but I don't need 8 because carbon only has 6. And if I had an even bigger element, it would go all the way up, and I'd put the next ones on another ring all the way around. So that's a pretty good looking carbon atom. Let's do one more just to get it, just to get some practice done. So I'm going to scoop my note sheet up. And I'm going to look over on the side of my periodic table in my room, and I'm going to say, let's do a bigger one. Let's do fluorine. So fluorine, according to my periodic table, looks like this. I've got an F for fluorine. I've got a 9 up here. And then the number on the bottom, I'm going to use the actual number I seen. It says like 18.988. Okay, so that's fluorine. So let's get started. Where do I start? Atomic mass number. Now when you have this number right here, 18.988, That's because that's an average of all the different types of fluorine isotopes in the world. So we're always going to round this to a whole number. So let's round 18.9888 up to 19. So I'm going to draw 19 stuff in here in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Whew, that's a big nucleus. Now of those 19, how many of those are protons? Oh look, there's that atomic number, 9. So we're going to color in 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of those are protons. I'll go ahead and make my little Q over here to remind me those are my protons. These clear ones right here are my neutrons. On the side, I think triangles look silly for protons. I think I'm going to go with X's. Triangles look silly as electrons. So let's go ahead and we'll go ahead and do some X's for electrons. All right, so let's think. How many electrons? Oh, that's right. I'm going to try to balance my number of protons. So I've got 9 protons. So I need 9 electrons. I'm going to follow my 2-8-8 rule. So we'll put our first 2 in the closest orbital. There they are going around the atom. Then I can put up to 8 more. Now I have to do 9. So let's do my second orbital around. So I've got 2. Let's go 3, 4, 5, 6, 7, 8, 9. And that's a pretty good picture of a fluorine atom. We got our nucleus, we've got our electrons here and here. We remember those electrons, they aren't just flat, they're actually in a cloud going, whoa, look at those crazy hands all the way around the atom. But for a picture, that's not too bad. You follow these simple rules using your atomic number and masses, you should be able to draw the first 10 atoms on the periodic table, no problem. One last thing, guys. I forgot to go over isotopes and ions with you. So write this down with me. We have isotopes and we have ions. All right. Now these words, isotopes and ions, they look very similar to each other, but they're quite a bit different. Let's start with isotopes. Isotopes are different versions of the same element, containing one extra or one less neutron, period. If I can find my green color pencil, we're going to say this is neutron is the keyword and versions right here is the keyword. So fluorine may have 10 neutrons right here, or fluorine may just have 9 neutrons. There are 2 different versions of fluorine, 2 different isotopes. Now ions are different than isotopes. They're not versions. They are positively or negatively charged atoms. How does an atom get a charge? Well, I'll tell you how. This is due to an unequal number of protons and electrons. Positively or negatively charged atoms due to an unequal number of protons and electrons. I would write down charged atoms. That's what I would highlight. Because remember, when we draw atoms, we assume there's the same number of electrons as these colored in protons. But we're going to come to find out that electrons are like money in the atom marketplace. And atoms trade these electrons and borrow electrons. And once they do that, they become these guys, ions, charged atoms. Very exciting stuff we're going to learn about here next week. All right, now you're finished. Let's go tackle drawing those atoms. All right, let's give it a try.